All right. The question is, which one of the following is not logically equivalent to this logical statement out here? Okay, so not is key out here. So we have this statement, and out of these four, we have to find which one is not logically equivalent to this thing. All right. So before I go on solving this, and uh, the two most important things that will be used to solve this problem, the two important ideas from mathematical logic are these. The first one is that this implication P implies Q is equivalent to not P or Q. That is the first idea. And the second idea is about negation, which has basically two rules. The first one of them is, suppose you have something like this. Suppose you have uh, something like this. All right, so this is equivalent to what happens in this case. So you have this negation and you have this there exists x. So what happens is this, when you take this negation inside this there exists x becomes for all values of x, and then this negation goes inside. Okay, and the same can be done for just the opposite of this. In the case when you have in the negation of for all values of x, and suppose you have q out here, this can be written very well like so. This becomes, when you take the negation inside, this becomes there exists x. Alright, and this becomes negation of q. So these things should be in your mind always, and these are the ideas that will be used in solving this particular problem. Okay, so let me first write what do I have there, what is given to me. So what is given to me is this negation, and then I have this there exists x, and then inside these brackets I have for all values of y I have alpha, and then I have and then I have for all values of z. Okay, for all values of z I have beta. Okay, so this is what is given to me. Okay, so this is what is given to me, and then I have to find that which one of these can be logically equivalent. Okay, so I take this thing inside, so this will obviously become for all values of x. That is like very fine, shouldn't be any problem with this. And if you look at this thing, okay, so this negation will go with this whole thing, and if you apply De Morgan's law, what you're going to get is you're going to get negation of this thing, and this, after applying De Morgan's law, this and will become or, and you will have negation of this thing. Okay, yeah, that's what you get. Okay, so now let's wait a little bit and try to see if you can compare it with any of these and you get something useful out here. Okay, so what is this? This is for all values of zb. This is this and this. So what I'm going to do is I'm going to write this expression as this thing. Okay, so what I'm going to write this is like this. So for all values of x is fine, and then this thing will, again I'll apply this same law. Okay, this law I'll apply. So this will become, this negation will go inside, and this will become there exists y, and this will becomes not alpha. Okay, and then I have or, and I have this negation. I'll leave it like this just for the moment, and I'll have this thing like this. So what is this? So if you can compare this with this thing. Okay, so suppose this thing comes before, so think of this thing as, suppose this is your P. Okay, and think about this as if this is your Q. So this is not of P or Q. Okay, like this, not of P or q, which means p implies q. So this will basically becomes, there exists x, and so this is p, so you can write for all values of z beta, and this will imply this, like this. Okay, so there exists y and not of alpha. Okay, and if you compare this with this thing, so this is the same thing as this, the option B. So your option B, you arrived at your option B by starting at this point. So this means that option B is logically equivalent to what was given to us. So this cannot be our answer definitely. Okay. Now what I'm going to do is I'm going to play with it a little bit more to see what else I can get from here. So what I'm going to do is I'm going to delete this lower part, and then I'm going to start again. Just a moment. Okay, so this is gone. So now what I'm going to do, this time I'm going to do it a little bit different, because now I'm looking at my option C. Okay, now you focus on option C. So in this case, your for all values of y is just like that, and this thing is changed because you see there exists z out here. So I'm going to change this one this time. So what I'm going to do is I'm going to write for all values of x, and this I'm going to leave just like that, and this one will become there exists z. Okay, and this negation will go inside. This is this simple law that we just saw before. Okay, so this is what you have now. Now what you do is, now again think of this as p and think of this as q. Okay, so think the p and q, and then again do the same thing. Not p or q, is p implies q. So which will give you, this will be equivalent to for all values of x, and this is p, so you can say that for all values of y, alpha will imply q, which is there exists z and not of beta. Okay, so you got option C also, so you could arrive at option C by starting at the thing that was given to you. So this is eliminated too. So now you're left with two options, option A and option B, option D, sorry. So now what happens is that, okay, so again this question should have only one correct answer. That's what this exam is all about, that there is only one correct choice. But it turns out that in this case both A and D are correct, and you'll see why. Okay, you'll see why this A is not logically equivalent to this, and you'll see why this D is not logically equivalent to this. So what do we have here in A? Let's look at this. So we have this thing, okay, and we have the same thing out here. Okay, we have this thing, and what do we have here? We have there exists z not beta, so which we can get from here. Okay, so which we can get from here like this. So what I have done is I have written this just like that, and out here I have written this as there exists z and not beta. So now can you say that A is logically equivalent to this? Can this thing imply this thing? No, because this implication, this negation goes with P. Okay, from here you can say that this thing implies this thing, which is your option C, but you cannot say that this thing. Okay, or you cannot say that Q implies P. Okay, so this A is not logically equivalent to what was given to us, and you'll see why D is also not logically equivalent to what was given to us. I mean, this is the kind of flaw these guys make. A lot of times when you have this exam, there should be only one correct choice, but I don't know, maybe they are a little careless, and there's more than one correct choice. And sometimes students waste a lot of time sitting in the exam that, oh, I'm getting two correct choices, and it's bad. Okay, so now you'll see why this thing, why your D cannot be the correct choice. So what do you have here? Oh, you have there exists for both. Okay, you have there exists Y, you have there exists Z. So what I'm going to do is I'm going to convert this thing for both of them. Okay, so this thing will go there, this will become there exists Y, and this is not alpha according to our law, and I'm going to apply the same thing again, and this becomes there exist Z and not of beta. Okay, so now again, can you say that this is equivalent to D? I mean, this is like P or Q. Is P or Q equivalent to P implies Q? I don't think so. So this is again not logically equivalent to what was given to us, and that is it.